All right, so here's our very first review. So we got today, tomorrow, and Friday. So please be ready for it. So what are we calling this? Review for final exam, and call it day 1. All right, so it's our first day to review. So hopefully we'll get through most of this from chapter 4 and chapter 5. All right, here we go. Let's change this to red. All right, now we're ready. Let's see if it works. Okay, we're good. All right, it says classify each triangle by its angle measure and by its side length. All right, so what kind of triangle is this because of the angle? What angle do we know? We only know one angle, right? We know this is a right angle, so what kind of a triangle is this? Talk to me. It's a right triangle. Very good. Okay, name it by, so let's write it down, might as well. So that's a right triangle. All right, let's name it by its side length. I got 2 equal sides right here. That's what those 2 means. So what does that mean if I got 2 equal sides? What do we call that thing? Isosceles. Isosceles. All right? So there you go. That's by the angle right there. This is by the side length. Let's do it here. Shouldn't take too long. Let's do it real quick. It doesn't say anything about the angles. You could call it a couple things, actually. Some of you guys said it's an acute triangle, which is fine. But what I was really looking for, it's well, that's by its sides, so that is going to be one of our answers. But by its angle, equiangular, right. So that's what I was looking for. I allowed you. This is also acute. All the angles are acute. So if you put acute triangle, it's fine. But this is kind of what I was going for. Angular, equiangular triangle, and all the sides are equal, so we call that what? Equilateral. To tell you the truth, if you put isosceles, because remember isosceles, at least 2 of the sides are equal. Are at least 2 of the sides equal here? Yeah. So you could have put equilateral or isosceles. You could have put equiangular or acute. All right, I would have accepted any of those. We good? All right. Some of these you're going to find are kind of easy because we've been doing that stuff for a while, like this one right here. Find the indicated measure. We've done this a little bit. So it says find angle A. All right, look at this triangle. This is 70, this is 70. So talk to me. That's 140, so what's this going to be? It's not going to be 140. It's going to be 180 what? Minus 140, which is 40. All right, so this angle right here is 40 degrees. That's the answer to this one. Angle ACB. Or ACD, sorry, ACD. That's this angle right here. You can find that kind of easy too. Almost the same thing. It's 180 minus 70. That's right, because look, this whole thing is a straight line, isn't it? So it's 180 degrees. Take 70 away from it, so it's 180 minus 70, which is 110 degrees, and that's what that answer is right there. Pretty easy, right? All right, it's been a while since we've done this stuff, all right? So let's watch. Might be good to take notes on this. It might. Anybody actually taking notes on this? All right, let's do this. It says, write a valid congruent statement and name the postulate. What? That's fine. You're going to do it at your desk? It's on your phone? What is it, Spanish or what? And you can do it on your phone? All right. As long as that's the only thing you're doing. All right, what about this? Here we go. Write a valid congruent statement, name the postulate. So why are and we want to show that justifies why they are what? Congruent. Do you remember stuff about congruent triangles? I got an angle here and an angle here. What do I got here? There's a side. Do you see how that side is the same on both those triangles? I'm going to go through quickly. I'm not like reteaching this to you, okay? This is just so that you can, it just jogs your memory a little bit, all right? You can always go back. This is chapter, what I say was, chapter 4. You could always go back to the chapter 4 videos, watch them, all right? But I'm just giving you a brief reminder of how to do this. So these triangles are congruent because of what reason? There's an angle, there's a what? There's a side, and there's an angle. And you got the same thing over here, don't you? You got that one arc angle, you got the side, you got that two arc angle. So those are congruent to each other. Well, what are congruent to each other? What do you want to call this top triangle right here? Call it WXY. That'd be easy. WXY. Remember what's really important about this? Is that this triangle is labeled with the same letters. So this is W, that's got one arc. On this triangle, which one has one arc? It's Y, so the Y has to go first, all right? So I went angle side, let's just do it like this. You went this angle and this angle, right? And then the Z and the X, right? I went YX. So which one has no angle mark down here? The Z does, right? And which one's got, this one's got 2. See, the Y has 2. This one, okay, that'd be good. One thing I was thinking of, have you gotten any pictures of yearbook kids like interviewing in the hallway and stuff? We need to do that. Somebody got you taking a picture? Okay. We need to get that so we get that page done. I do. There you go. All right. So what do we got? This Y's got 2 arcs. What's got 2 arcs over here? The W. Of course, it's the only one left. All right, so there you go. So that is the congruent statement. That's the congruent statement, right? What's the postulate? Where you already said it's what? Angle, what? Side, angle. So that's the postulate, angle, side, angle. So that's what you need to get that one right, okay? Look at this one. I'm not going to write them down. I'm just going to do them real quick. So again, you got this side that's shared by both of them. So I'm going to put 3 tick marks here. All right, what's your reason? Let's do the reason first. Let's do the second part first. What's the reason? Side, side. No angles. No angles are given to you. Side, side, side. All right, I'll write it down. I said I wasn't, but I'll do it. Okay, that's side, side, side. So if you wanted to name, thank you. If you wanted to name this triangle on the left, you could use any of those 3 letters. It doesn't matter, but I'm going to call it QRT. So triangle QRT is congruent. If I go QRT, what do I have to go over here? No. Look, if I went the top one, the left one, the bottom one, then I go the top one, this one across from it, so it's QST. So triangle QST. All right? What about this one? This one's easy to figure out the reason why. It's what? Side, angle, side. Side, angle, side. So that's my reason. I'll put that second. What do you want to call this? Triangle ABC? So triangle ABC is congruent. Now watch. A is opposite the one with 2 arcs. Which one's opposite the one with 2 arcs over here? The F. So the F has to go first. Put a triangle symbol. And then the B is the one with the 1 arc. Which one has the 1 arc? E. And then there's only 1 letter left. What could it be? D. And there you go. So that's how you do those. All right, go back, watch the video on that lesson if you don't understand why we did what we did. Now this one's a little different. It says state what additional information is required, all right, in order to tell these triangles are congruent because of angle, side, angle, all right? Well, there's my angle, right? The side's given to you, isn't it? So I can put a little tick mark right there. What else must be equal to each other, congruent to each other for these triangles to be congruent? This angle right here, agreed? If I was going to go angle, side, angle, there's my angle, there's my side, and then there's my other angle, right? So what additional information is required? Well, this angle must equal this angle right here. What do I call that angle? I can't just call it angle B, because that could be angle B, that could be angle B, the whole thing could be angle B. So I can't just call it angle B. What would I call it? Angle A, B, not C, not the whole thing, just this one, just this angle right there, ABD. All right, so I would say that angle ABD must equal what? If I went ABD, what am I going to do here? CBD, angle CBD. Make sense?
Yep.
All right. That's the only thing you didn't know. But if you were to say that they were congruent because of angle side angle, you would have to know that that side is equal, which is already shown in the picture, right? It's shared by both triangles. So I already know that, but this is the one thing right here, this angle and this angle must be equal to each other. So that's what I did there. All right, let's do the same thing here kind of quick. It's side, side, side. You already know that xy and xy are congruent or equal to each other. What's the only one that we don't know that should be equal? Well, this one and this one, correct? All right, in order for it to be congruent because of side, 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 I don't have to say anything about the angles, just about the sides. Again, I already know just by looking at the picture that xy equals xy. Okay, what's the additional information that's required? Well, it would be this one and this one. Okay, wy must equal what? You could go xz. I'm going to go zx, right? Because it would be going the other direction. Either way is fine. We'll just do it like that. Actually, if you put a line segment, put congruent, that's kind of how they want you to do it. All right, what about this one? Side angle side. Well, there's a side. You already know that this angle is equal to this angle. Okay, that's not additional information. That's already been told to you because of the picture right there. These are vertical angles. Vertical angles are always equal to each other. So we already know that. We already know that this side and this side are equal. What's the other thing we got to find? What's the additional information that's required? That this side right here and what else? See, there's angle side angle. Then I got angle side what? Or sorry, I said it wrong. Right, I said it wrong. Side angle side, and this is what? Side angle side. So what must be true? LK must be equal to what? KN or NK. That's an L. Looks like an angle, but that's an NK. All right? And there you go. Those are, looks like that. Okay. Is this coming back to you? Yeah. It's been a while. It's been since what? January, I think. Since we did this stuff. Or somewhere, December, January, something like that. All right, here's more of this stuff. Write a triangle congruent statement. Again, what is that? It's triangle this is congruent to triangle that. Write a triangle congruent statement and name the right angle or the right triangle congruence theorem that justifies it. And they give you a choice. That's nice. It's nice of me. It's not they, it's me. I put it on here. All right? So I give you a choice of what it's going to be. So let's take a look. Well, we know this side is shared by both triangles, so we know that's equal to each other. We know we have a right triangle. All right? That's when we use all these things, and when you have right triangles, leg, leg, hypotenuse, right? You can't have a hypotenuse unless you have a right angle. All right? So what else do we know? Well, I know these two sides are parallel to each other. This is a transversal. Almost forgot the word. All right, so that means this angle and this angle are equal to each other. So what do I got? I got a hypotenuse of both of them. Isn't this the hypotenuse? You see AC? That's the hypotenuse of this one. It's the hypotenuse of this one. So I'm either going to use hypotenuse angle or what? Hypotenuse leg. Well, what's the other thing that I know? I know these two angles are equal to each other. So which one do you think I'm going to use? Okay, hypotenuse what? Angle. All right, it says write the congruent statement and then give the theorem that justifies it. So I'm going to use hypotenuse angle. Now, what triangles are congruent? Let's call this triangle ABC. Is congruent to if I go ABC, watch. If I go A, B, C, then what do I got to go? A is the one with no arc, right? So which one over here, which triangle or angle over here in this triangle has no arc? The C. So I'm going to put C. And now if I went B, B is the right angle. What's the right angle over here? D. And then what else is left? It's just the A. Correct? Because C's got the one arc, A's got the one arc. There you go. That's how you do that problem. All right, I said I wasn't going to do every problem, and I have been doing every problem. So I'm just going to skip those two. There you go. If you didn't want to watch that whole chapter, every lesson in chapter 4, which would take you a long, long time, I don't think anybody's doing that. And I don't think anybody's going to do what I'm going to suggest. But here's an easier suggestion. You could go through the review for the chapter 4. I probably have a video on there. I don't know 100%, but I'm pretty sure because I pretty much did a review for every chapter. You could do review for chapter 4, okay, go to the playlist, go to chapter 4, there should be review for the chapter 4 test, and then most of this stuff should be on there, all right? So that might be something you might want to watch as well. Okay, definitely watch this one, but you could watch the other one as well. All right, let's do this. Find xz. Well, very good. So look, what does this do? If this side is equal to this side and this side is equal to this side, this is the midpoint. So we call this the what? The mid, what is CD called? The mid what? Not point, but segment. Remember that? Coming back to you. What do we know about the mid segment? That mid segment is half of the opposite side. So what does the opposite side have to be if this is half of this? It's got to be 14. And that's it. Super easy. Do you agree? Yeah. What about this one? VU. So again, this is a midpoint, this is a midpoint, so VU is the mid segment. Remember, the mid segment is half of the third side. So if this is 24, this has to be 12. Again, super easy. Now this one you got to do a little bit of work. So watch very carefully. This is definitely something that if I was going to make up, well I am, okay, when I make up the midterm, I'm looking at this, I'm like, yeah, they should know how to do this. So let's do it. What do we got here? This is half of this. Or you could say that SQ, right, that longer side is twice as big as the shorter side, right? So let's write that. So SQ is twice as big as ZY. So what is SQ? It's 3x minus 8 is equal to what? It's not equal to x plus 2. They're not equal to each other, but this one is what? Twice as big as this one. So how do I do twice as big? 2 times x plus 2. See what I did? That was the key to this problem right here. All right, was to set it up correctly. So that's how you set it up. Now let's do the math. Okay, we've been doing this math all year, so let's do it kind of quick. Equals, distribute the 2. So that's 2x plus 4. Subtract a 2x from both sides. Let's do this in the same step. Add an 8 to both sides, right, to get it to the other side. That cancels, that cancels. 3x minus 2x is x. This is 12. Is that my answer, though? Do I circle that? No, because it says find what? YZ. YZ is this one right here. So I know what x is, so what do? 12 plus what? 2, which is 14. So x or YZ is equal to 14. All right. It's the same idea as these, but a little bit more involved because you had to solve for x, plug back in, and all that stuff. All right, let's do another one. Ooh, do you remember slope and distance formula? This is something you're going to need to study. All right, you're going to want to make sure that you remember these formulas. I'll write them down for you so you can remember. So the slope. How do I find the slope? Do you remember that? Slope is change in y over change in x, or you could go what? y2 minus y1 over x2 minus x1. You may have memorized this for the chapter 4 test, but we haven't done it in quite a while, so it may not be in your brain, at least in the front of your brain. All right, it's probably back there somewhere, so you got to bring it back up front again. So make sure that you look at this and you understand what that formula is. All right, so how do we use that formula? Well, we got to find DE. What is DE? That's also mid-segment, isn't it? Now look, I don't know the point here, do I? I don't know the point D, and I don't know point E. There is a way to find it. I'm not going to go through that. Okay, I'm going to do it another way that I like a little bit better. First thing I'm going to do is find this, well, yeah, it's a mid-segment. So the length is half of this, but also what's true about these? This is what to this? Well, we already said that. We already said that this is half of this. Those arrows, what do they mean? Parallel. That's right. They mean parallel to each other. So they're parallel. What do I know when the slopes are parallel to each other? If two slopes are this, look, that's slanted the same exact way that that's slanted. So what's true about the slant? What's true about the slope? They're the what? They're the same. Okay? They're exactly the same. So if I can find the slope of AB, because look, they give me the points to AB, don't they? If I can find this slope, then what's the slope of DE? It's the same thing. All right, so let's do that. Let's find the slope of AB. All right, so I'll put slope and I'll put a little AB right there so we know which one we're doing. Again, what do? We go y2 minus y1. So which one is my y? And again, it doesn't matter what order you subtract them in. As long as you subtract the y's in the same order as you subtract the x's. So what do we got? -1 minus what? 5. Good. All right, so that's the y's. Let's subtract the x's in the same order. So if I started with -1, what am I going to have to do with the x? Do -4. So I got to go -4 minus what? What's the x over here? 6. All right, we work that out. That's this slope. And then DE is going to be the same exact slope. So we just put the same answer for both of them. All right, let's work this out though. Let's do it down here. -1 minus 5, add the opposite. That's -6. -4 minus 6, add the opposite. -10. Always simplify it. What's a negative over a negative? It's positive. 6 over 10, what number goes into both of those? 2 does. 2 goes into 6 3 times. 2 goes into 5, or 10, sorry, gave it away, 5 times. So what's your slope of AB? It's 3 over 5. Now, without really doing any work at all, what's the slope of DE? It's the same exact thing, 3 over 5. Okay, so these need to be the same. If they're different, you know one of them at least is going to be wrong. Make sense? All right, again, this is just a quick review. I'm not teaching it from scratch, so keep that in mind. Let's get rid of this. All right, now we got a clean slate again. Now we're finding the length of the segment. What are we finding? We're finding DE and we're finding AB again, but this time we're finding the length or the distance, right, from one point to the other. That means we have a formula. What formula are we going to use? The what formula? I said the word just a second ago, so it would be in your head. The what formula? No, not Pythagorean theorem. I said we're finding the distance between one point and another. So what formula are we going to use? Are you serious? Thank you. One person? I like shouted out distance so that you... I'm trying to help you out, aren't I? Trying to make this easy for you. All right? You guys aren't taking it in. One person is. So Ben, thank you for that. All right, so the distance. We got to do the distance. Let's write down, we're going to write it. Let's just put it right here. So the distance formula. You got to know it. You got to memorize it. You had to memorize it for a quiz. You had to memorize it for this test. You're going to have to memorize it for the final. Remember this? Big old square root. Remember inside of it? You got 2 parentheses squared. If you don't, you better study it because it's going to be on the final. All right? And then what do we put in here? x1 minus x2. And then this is y1 minus y2. You could go x2 minus x1. Does not matter what order you subtract them in. Okay? Do you remember this? This has come back to you? All right. So let's find the distance. Now look, I can't find the distance of DE again because I don't know that ordered pair. And I don't know E, that ordered pair. But I can find AB. Once I get AB, then what can I do to find DE? Remember, this is a mid-segment. If I find this one, what is the mid-segment? It's how much? It's smaller. It's how much smaller? Well, no, it's smaller. It's half this, okay? So once I get AB, whatever it is, then what do I do to get DE? Just divide it by 2, okay? All right, so we got to find AB. Let's put some numbers in. Distance equals big old square root. Okay, I always do this. Remember I called this the shell of the formula? It's kind of like the outside of it. Now we're going to put in the stuff, all the guts, all right? x1 minus x2. So what do? Take the x's and I subtract them. This time it doesn't matter what order I subtract them in, but we'll do the same order. So it's -4 minus what? Minus 6. So we get -4 minus 6. And then we do the y's. So that would be -1, right? That's a y. And then the 5 minus 5. All right, let's just do the math. Negative 4 minus 6 is negative 10. All right, you square it. You're squaring a negative, becomes a positive. What's 10 squared? Let's do that in our head. What's 10 squared? 10 times 10. It's 100. Plus, negative 1 minus 5 is negative 6. If we square that, that's a 36. Again, when I square a negative, it always comes out to be a positive. When I square any kind of number, it always comes out to be a positive. Yes? Yeah, that's fine. So what is that? The square root of 136. That does simplify. I'm not going to make you simplify that square root. Just keep it. Square root of 136. Everybody okay with that? Yeah, because that makes it so much easier. So this is the square root of 136. That's what AB is, right? I could put it right here, square root of 136. What's a super easy way to take half of 130, or square root of 136? Just do what? Divide it by what? 2. And that's your answer. Just leave your answer like that. It's perfectly fine. Square root of 136 over 2. You can keep it just like that, and I'm good with that. All right? Don't put it into a calculator. Don't get a decimal answer. You don't even have to simplify this square root. All right? Now, there is a way to simplify it, but for you guys, I'm not going to worry about that. All right? That's that. Make sense? When's this supposed to be over? 38. I think we're running, they said we're going to run a little long in this class. I probably won't teach the whole entire time, but I will go a little bit over what we normally would. Ooh, this looks a lot better, doesn't it? Hang on just a sec. All right, so let's go back to this. I'm not going to give you a big explanation of this. I'm just going to tell you what these answers are, okay? So just memorize them. Yes, give me a pass. All right, so here we go. It says name a point of concurrency. Do you remember that orthocenter and incenter and all that kind of stuff? Okay, that's what you're going to have to remember. All right, so here we go. Number 1, it says, make sure this is the right one. Yeah, I think this is the right one. Yes. All right, so correct. I think I grabbed. Oh, no, that's right. That's right. I got it mixed up. All right, so the triangle's altitudes. All right, by the way, this is chapter 5. Okay, if you find the altitude of the triangles, that would be the orthocenter. Orthocenter. Okay, if you bisect the angles of the triangle, you're going to find the incenter. Just remember which one's which. Okay, perpendicular bisectors will be the circumcenter. And then the medians would be the centroid. It's been a long time, okay? Myself included, okay, I forget some of these. Okay, if you haven't done it in a long time, you forget them. So this is something you want to go back to. You want to memorize them so that you remember which one's which. Okay, the altitude's the orthocenter, the bisecting the angles. The angle bisector is the incenter, perpendicular bisector, circumcenter, the median, centroid. Just remember which one goes with what. All right, it's just a memorization thing for you. All right, let's do this. All right, let's find these. Some of these are super easy to do. I think, if I recall, this test was a really high-scoring test for you guys. All right, so here we go. AB, we've got to find AB. Well, if this side is 5 and if this side is a perpendicular and these two are equal, that means this is an isosceles triangle, okay? Again, I'm not going to teach it from scratch on why all that stuff's true, but that's something that we learned way back when we did this. So if this is this is 5, then this is 5. So AB is 5. Angle C. Well, what do you think? If angle A is 80 degrees and these two sides are equal, what do you think angle C is? Without doing any math, it's also 80 degrees. Very easy if you understand the relationships here. All right? This is the centroid. How do we find the centroid? By bisecting the sides. Okay, the angle's medians. What's a median? It goes from an angle to the midpoint of the opposite side. So on this one, this is the one where the short side is, let's see, the long side is 2/3. So this is 1/3, this would be 2/3, okay? So what do they tell you? Find DR, find this one right here, if BD is 12. So here's BD, that's 12. Okay, this would be, let me make sure, yeah, this is 2/3 of the whole thing, but it's twice as big as this one. Okay, so this would be 6, exactly right. Okay, so if this one is 12, this would be 6. What if they gave it to the other way around? What if they said that this was 4, QD was 4, and they asked for QC or DC? That would be 8, okay? Everybody see that? Pretty simple. All right, so that's the shorter one, that's the longer one. It's been a while. Again, it's been a long time since we've done these, so stay familiar with it. Watch the review for Chapter 5. Okay, you don't have to watch every single lesson for Chapter 5. That'd take forever. So just watch the review that I did for Chapter 5, and hopefully that stuff will come back to you. All right, so that's what I would do for this. Okay, the night before you take, well, not the night before, I'd spread it out into a couple nights, okay? One night, watch the Chapter 4 review. One night, watch the Chapter 5 review, and so on. It's all on YouTube, so check it out. Watch this. It says find RP. Where's RP? It's this one right there. Well, what's true about all three of these dotted lines? If this is the in-center, they're all equal to each other. So if PS is 5, very, very easy. What is RP? That's also 5. That's it. Okay? Super easy. Didn't have to do any math with that. Right? Let's do this one. This is the circumcenter. The circumcenter is the same distance to all three vertices. So all three of those dotted lines, again, are equal to each other. All right? So that's easy to remember. So it says find PA if they tell you PB. Well, if PB is 17, then what is PA? That's also 17, all right? Super easy. So PA is the same. What about this one, CY? This one right here. Now, on this is the perpendicular bisectors, all right? So this is perpendicular and it's a bisector, so Y is the midpoint, X is a midpoint, Z is a midpoint of that side. So if CY, or find CY if AC is 24. Now watch very carefully. AC is 24. So this right here is how much of the whole thing? It's half of it. So CY is 12, and that's your answer. Number 10 is 12. The math is very easy. You just have to know the relationships. And again, I'm saying this a million times, but it's been a while since you've done this. So make sure that you go back and you watch the videos on it. That's all I can say. If you don't, you haven't done enough. Some of you guys are knocked out in here, so you're going to have to make sure you watch the videos. That could be a problem with doing videos because you're probably thinking, well, I don't have to watch what he's doing right now because I'll just go back and watch the video. But I have a feeling there'd be just as many people sleeping, don't you? Even if I didn't have the videos. I think so. All right, what are we going to do this? Order the angles from the smallest to the largest. So how do I know what the smallest angle is in here? Do I need a protractor and sit there and measure it? No, I can look at the sides. What's the smallest side? This 12, isn't it? How do I know which one the smallest angle is? I look where? I look opposite, okay? I look opposite. So if this is the smallest side, again, we're putting it in order from smallest to largest. So what's the smallest angle here? Angle what? Angle C. What's the largest angle then? Well, look and see what the largest side is. The largest side is 18, so what's the largest angle? A. So what's the one that's in the middle? B. So it's angle C, angle B, and what? Angle A. This is the same exact thing, except you need to draw the triangle. All right? It doesn't have to be to scale. Okay, just draw a triangle. This is RPQ, or RQP, sorry. Doesn't make any difference. RQP. And you put the numbers in. So what's QP? QP is this one. That's 15. RP is this one. That's 25. And then RQ is 13. Put that right there. Again, it does not have to be to scale. Now, which one's the smallest angle? Just by looking at it. Which one? P, right, because it's opposite to 13. 13 is the smallest side. Angle P is opposite, so angle P is the smallest. Which one's the middle one? R. And then which one's the biggest one? Q. And that's all there is to that. Not that difficult. This is the same kind of thing. I'm not going to go through, well, I'll do the first one. I won't do this one, right? This one, though, they give you the angles. You got to find the smallest side, the shortest side, all the way up to the longest side. So what do you think you look for? The smallest angle. If that's the smallest angle, which one's the smallest side? The one that's opposite, right, XY. So that's the smallest side. Which one's the medium one? Well, it's opposite the 50. So what's opposite the 50? YW. And then, of course, opposite the 100 is XW. That's the biggest side. This is the same thing, just redraw the triangle just like we did right there. Again, it doesn't have to be to scale. All right, look at this. State if the three numbers can be the sides of a triangle. How do I know if it can be a triangle or not? I take the two smaller ones, I add them up, right? So if I add those up, what do I get? 17. Is 17 bigger than 13? Yes, it is. If you add those two numbers up and it's bigger than the third one, yes, this is a triangle. So I would say yes. What do you do here? Add the two smaller ones together. What do you get? You get 17. Is 17 bigger than 20? No, it's not. So is this a triangle? No, it's not. That's how you do that. Again, the math is easy, but you got to know what it means. You got to know what to add up. You got to know if it's bigger, that it means it is a triangle. If it's smaller, then it's not a triangle. That's what you got to do. Okay, let's just do one of these. Find the range of possible lengths for the third side of a triangle. Okay, so it's going to be between, so I always like to use X, is between, remember doing this? Okay, X is greater than this and it's less than this. What do I do with these two numbers to find out what the smallest one's going to be? What do I do with those two numbers? I subtract. 13 minus 7 is 6. And then what do I do to those two numbers to put over here? I add them together. 7 plus 13 is 20. That's how you do it. You can go back, watch the video. If you're not sure why we do that, I give an explanation of that. But that's what we end up doing. What's this in your head? X is between what and what? Really quick, come on. 1 and 7. Right, X is between 1 and 7. How'd you do that? You subtracted to get the smaller one, you added to get the bigger one. Okay? Simple. All right, we're almost done. And I'll quit right here, and we'll just wait for them to dismiss us to chapel. All right? Let's put some stuff in here. It says AB is 5, so I'll put a 5 right there. AD is 8, so put an 8 right there. And DC is 7, so DC is 7. All right, this one is similar to what we did up here, but it's a little bit different. Now again, this is not exactly to scale, all right? I mean, look, that 8 definitely looks bigger than that 5, doesn't it? That's why when I say it's not to scale, that means that should be bigger than this, and it definitely doesn't look like it, but that's okay, we can still do this. The question says, take a look at angle CBD Where's CBD? This one right here. And then look at ABD, this one right here. I'll put 2 arcs there. So CBD, is it bigger? Is it smaller? This one right here. Is it bigger? Is it smaller? Is it equal to this? You can't just look at it and say, well, I don't know, it looks a little smaller than that. We're not going by what it looks like. What are we going by? We're going by what it's opposite. Okay, what is it opposite? This is opposite the 7. This is opposite the 8. So this first angle right here, this one right here, okay, the one with 1 arc, has got to be smaller. So CBD has got to be less than ABD. See that? So that's what we're doing here. Oh, they also tell you this is BC. All right? We call this the side angle side inequality theorem. You don't need to know that, but that's what they call it. All right? That's how you do it. So less than. That's a less than symbol. It's not an angle symbol. It's a less than symbol. All right, let's do one more and we'll be finished. Let's get rid of all this. There we go. Clean slate. All right, let's put some stuff in here this time. AD is 10. DC is 10. It says ADB. Where's ADB? ADB. That's this bottom left one right here. That's 75 degrees. And BDC, where's that? There's B, there's D, there's C. So it's this one right here. That's 72 degrees. What I want to do is I want to compare AB, this one right here, to BC, this one right here. Which one is bigger? Which one is smaller? So it starts off with AB. So AB, this side right here. Now again, you can't just look at it because it's not drawn to scale. You can't just look at it without any numbers and say, oh, that side's bigger than this, or that side's smaller than this, or that side's equal to that. You can't do it. But what you can do is this. You can see what angle it's opposite. This side is opposite a bigger angle than this side is, correct? So that means that this side has to be what? Bigger than the side opposite the smaller angle. So AB has to be greater than BC. And that's how you do it. There you go. 2 tests, 1 class period. That's not bad. So what tests are we doing? 4, 5, we did today. And then 6 and 7 we'll do tomorrow. And then a little bit of trig. All right? Everybody good? All right, I'm sure they're going to dismiss us in a few minutes because it looks like elementary just got out. So that'll be it. This is recorded. It'll be on YouTube. Make sure you look at it before you take this final exam.